Lesson 4. Igneous rock formation. To start with, I want to go through the structure of the Earth. On the outside we have this crust, a solid layer, despite the water as it's classed as solid, made up or comprising of tectonic plates, which are lumps of floating crust. So there's gaps in between, and these tectonic plates float on a semi-solid, so it's a liquid/solid mantle. It acts as both. The outer core is a liquid, a molten rock liquid, and the inner core is solid. And the reason it gets so hot is because of radioactive decay, and that radiates out and eventually out to the crust. Some key definitions before we start looking at igneous rocks. Firstly, extrusive. Extrusive, by the nature of it, exit outside, and this is lava. So when the molten rock comes outside and starts to cool, it's classed as extrusive, and this is lava. On the inside, so the molten rock as it works its way up through the volcano, molten meaning it's in a liquid state, is known as intrusive. So any rocks formed in here is intrusive, so within the structure, intrusive, and it's known as magma. Lava on the outside, magma on the inside. Extrusive, intrusive. All igneous rocks are formed from the melting of rock, so usually metamorphic rock that's been pushed down, eventually gets so hot, rather than just the bottom's changing, like in metamorphic rock, it changes state. It goes from a solid into a liquid, and so igneous rock is formed from this liquid cooling and solidifying back to rock. Now it solidifies one of two ways, and usually in one of two places. Extrusive, outside, so sometimes it will form outside. Intrusive, sometimes it will form within the Earth's crust itself. When the rock forms outside, it cools quite quickly, and as it cools quickly, you get some of these big air pockets forming as gas tries to escape from within the rock, and you get no particular intricate layered structure here. When cooled much slower, sometimes over the course of several thousand years, you get a very intricately dotted rock. This is granite, and you can see many crystals starting to form, and large crystals as well, and that's because of how slowly, over the course of several thousand years, this rock develops. The science behind igneous rocks. Magma is under incredibly high pressure. So under the crust, under the volcano, you get a very high build-up of pressure. Eventually, this explodes. You get this eruption, and it scatters, it throws, the pressure goes up, and it throws a huge amount of rock, gas, carbon dioxide, etc., out of the top of the volcano, into the atmosphere and around. When igneous rocks form very quickly, you get air pockets, as mentioned in the previous slide. You get this build-up of air pockets, and this is a rock called pumice. Pumice is formed so quickly, it's formed in between, coming out in a liquid state, so sort of a flying splat, if you will, of liquid, and it solidifies on the way up as the gas escapes out the rock. Virtually as it hits the ground, it's solid, so it solidifies that quickly. As a result of that, you get a rock covered in holes, and it is such a low density it can float in water. So a rock that floats in water. Conversely, intrusive igneous rock is formed very slowly around this sort of region. So providing the earthquake or the volcano doesn't erupt or the tectonic plates don't move, you'll get a formation of intrusive igneous rock that cools very slowly, and it cools to form very large crystals, as you can see in the diagram here. A summary of the rock cycle. When describing the rock cycle, you can start at any point, whether it's weathering or sedimentary. It's a cycle, it's a continuous movement of rock around the lithosphere, so the rock layer, it's a lithosphere. I'm going to start with weathering, just to run you through it. Weathering, as we know, is the breakdown of very small bits of rock into sediment. Whether this is done by acid, in the form of acid rain, whether it's done by the wind, rain, sea splashing on it, it's a physical, mechanical movement, or whether it's done by plants, animals walking on it. This is weathering. Weathering drives the rock cycle. So the rocks are deposited, sedimentation takes place. Remember that force, that pressure pushing down, compresses the rock and forms sedimentation, or drive sedimentation, the cementation of rock together. As this continues its journey down, it's heated and pressed, and this changes the bonds, changes the chemical structure of the rock, and this forms a metamorphic rock. To morph is to change, so a metamorphic rock. However, this is not a change of state, it is just a change in the chemical bonds. The rock is the same, which is why you can see the layers in a metamorphic rock. If we then melt that metamorphic rock, by the heat of the magma, we start the igneous rock formation process. So as we melt it and cool it again, we can cool it very quickly up here, so if it's thrown out of the volcano, it will cool quickly, and that'll be a extrusive igneous rock. Or if we cool it around here and dig it up, or it's exposes after enough weathering, it is an intrusive igneous rock. Eventually, that rock, whether it's metamorphic, sedimentary, igneous, is weathered again, and the cycle starts. And so we have this continuous movement of rock around the lithosphere.